Page 200, lesson 3.6 is on compound inequalities. A compound inequality has two distinct inequalities joined by the word and or the word or. So two different cases. If we have the word and, then we will end up with an overlap of the graphs. We'll talk more about that in a little bit. I think it'll kind of make sense as we go along. And then if it has the word or, then it contains each graph of the two inequalities. It's got kind of separate pieces. And the deal is, we'll talk about in a minute, if you have the word and, you can rewrite those as a single inequality. So for example, we'll get into this in a little bit, but if you have x is greater than or equal to 3 and x is less than or equal to 7, that could be rewritten this way. And a couple ways we could read that. We could read that as x is greater than or equal to 3 and less than or equal to 7. Or we could say that x is between 3 and 7 inclusive. And inclusive, like the book says, means it includes both the 3 and the 7. So if you look at problem 1, they want us to write a compound inequality. So for part A, all real numbers greater than -2 and less than 6. So to start with, they just wrote the two inequalities that would make up that compound inequality. And then we can just kind of think about what's happening here. What they did, this first one, they switched it around. If n is greater than -2, that means -2 is less than n. And then if you'll notice here, -2 is less than n, and n is less than 6. Basically, that means that n is going to be in between -2 and 6. And if you can get that based off of this idea, then that's fine. If it's greater than one thing and it's less than another thing, that means it's going to be in between those two things. So we can rewrite it that way as our compound inequality. So -2 is less than n is less than 6. On the number line, then, if we were graphing that, we would have an open circle at -2 going to an open circle at 6. And we'll talk more about interval notation. We can do interval notation with this, but we'll get into that in a little bit. Part B, all real numbers less than 0 or greater than or equal to 5. So less than 0 or greater than or equal to 5. We can write it like that. And that's basically got two separate inequalities with the word or in between. So if t is less than 0 is going to be an open circle at 0 going to the left. And then greater than or equal to 5 is going to be a closed circle at 5 going to the right. So if you look at the got at 1, it's kind of the same idea. So number 1, part A, they want all real numbers that are greater than or equal to -4 and less than 6. So we could say x is greater than or equal to -4 and x is less than 6. So if it's greater than one thing and less than another, it's going to be in between those. Or you could do like the book did and rewrite that if you want, but ultimately it's going to end up -4 is less than or equal to x, which is less than 6. That would be our inequality, and then we could graph that. So we'd have a closed circle at -4, we'd have an open circle at 6, and then our solution is somewhere in between there, or it could be equal to -4. So it's kind of that segment in between, and then including -4 as well. Part B. They want numbers that are less than or equal to less than or equal to 2.5 or greater than 6. So with the word or, we're going to have two separate parts to our graph. So less than or equal to 2.5 is going to be a closed circle at 2.5 going to the left. Greater than 6 is going to be an open circle at 6 going to the right. Part C just asks what's the difference between x is between -5 and 7 and x is between -5 and 7 inclusive. The difference is if it's inclusive, it means it includes the -5 and the 7. If it doesn't say inclusive, it doesn't include either one of those points. Problem 2 talks about solving compound inequalities with the word and. There's a couple ways you can do that. One way, what the book is doing here, is they are splitting this up. And they're saying, okay, let's look at the left part of this, and then let's look at the right part of this. And let's solve each part of it, and then let's join it back together. That's fine. There's another way, which the book does actually talk about in a little bit here. Another way we can do that is to just work with all three parts at the same time. So what we're doing is trying to get the variable by itself. So the variable is in the middle part here. With the variable, they're subtracting 4, so we can add 4. What's different is that when we add 4, we have to add it to all three parts of the inequality. And when you do that, essentially you're saying m is kind of in between 1 and 5, but including 5. I'm sorry, I added wrong here. -1 plus 4 is 3. Okay, so it's in between, and you notice that's the same answer the book has here. Okay, so you can do that to all three parts and solve it that way. So on this one, on the trying to solve, first thing is they're subtracting 4. We could add 4 to all three parts. And then they're multiplying, so we could divide by 3. The only thing you have to watch for if you do the problems this way, which you'd have to watch for anyway if you were working a problem out, is if you ever multiply or divide by a negative, you have to switch your inequality signs. And so then you may want to even kind of change the direction of what your inequality is looking like. So this would be basically between 2/3 and 6. So 2/3 would be here, less than 1 somewhere. And it's in between both of these, so open circles. Okay, and we didn't have it on this problem, but just to mention it, if you get down to a point where you have, let's say you have 4 is less than -2x is less than 8, what you'd have to do is divide everything by -2. When you divide by -2, dividing by a negative is going to switch your inequalities around. And so at that point, probably in order to graph this, it would be easier to change the order of these things. Watch your direction of your inequalities. As long as they're opening towards the same thing as they were before, then you know you've done it correctly. The next part of the book talks about how you can work on all three parts of the inequality at the same time. So problem 3, and this is kind of an application problem they're doing here also. So to earn a B on your algebra course, you must achieve an unrounded test average between 84 and 86 inclusive. You scored 86, 85, and 80 on the first 3 tests. What possible scores can you earn on the 4th and final test to earn a B in the course? Okay, so for our grade, we're finding our average. We've got 3 tests already. We've got 1 more, so that's going to be a total of 4 tests. So you can see the middle part here is looking at what would our average be. And the deal is, though, we don't know what that 4th test is. Okay, but if we add those 4 scores, divide by 4, we want that average to be between 84 and 86. So you can see they've literally put it between the 84 and 86 in the inequality. The first thing you'd want to do here, you could combine the 3 scores that you know. You add those together would be 251. And then at that point, in order to solve for the variable, remember with the variable, this numerator, you could think of this numerator as being in parentheses. It's got this force field around it, so we can't penetrate that at this point. So anyway, that numerator, that part is being divided by 4. So what we could do is multiply all 3 parts of the inequality by 4. And then that eliminates the fraction. At that point, you could say they're adding 251. You could subtract 251 from all 3 parts. And they're just showing it a little bit different in the book. They're just writing some extra stuff there that we don't really have to write out. But and then it ends up basically that last test would need to be between an 85 and a 93 inclusive. So if you look at the got at 3, they've got a similar scenario. So if you had a 78, 78, and a 79 on 3 tests, is it possible for you to earn a B in the test? Assume that 100 is the maximum grade you can earn. Okay, so we're trying to find our 4th test so that when we average those 4 grades, we want it to be that we earn a B. So we want it, once again, to be in between 84 and 86. So this is really not much different. So kind of if you just follow along here, it's really the same process as what we did before. We're going to add 78, 78, and 79 together. So that'd be 235. Okay, and then we'd want to get rid of the fractions, so we'd want to multiply all 3 parts by 4. And then the last step would be to subtract 235. So if you do that, you'd have to get between 101 and 109% on the test. So that's, we're going to assume, not possible if 100 is the maximum grade you can get on the test. Solving a compound inequality that has the word or is something that makes either part true. So if it works for this part or this part, as long as it works for one of them, then it's fine. Then it's a solution. So problem 4, what are the solutions of these inequalities? What we're going to do is just solve for them one at a time. So the first one, they're adding 2, we can subtract 2. And then they're multiplying, we can divide by 3. So we got t is less than -3. On the other one, they're adding, so we can subtract 5. And then they're multiplying, so we can divide. Now watch this. It was less than. When you divide by a negative, that's going to switch your sign around. Notice it becomes greater than. So t is greater than 1. So t is less than -3 or t is greater than 1 would be our solution there. And then when we graph that, we could graph that on the number line. Open circle at -3 going to the left, open circle at 1 going to the right. So similar idea if you look at the got it for, we're just going to solve those out and then graph those. So the first one, they're adding 7, we can subtract 7. And then they're multiplying, so we can divide. And I'm dividing by a negative, so that is going to change my inequality. Negative divided by negative is positive. On the other side, or the other inequality, they're adding, so we can subtract. They're multiplying, so we can divide. This time we're not dividing by a negative, so we're okay. So y is greater than 3, or y is less than or equal to -2. And then if we graph those, greater than 3 would be an open circle at 3 going to the right. Less than or equal to -2 would be a closed circle at -2 going to the left. The next thing they talk about in the book is interval notation. Interval notation, we've already talked about. So parentheses doesn't include the endpoints, brackets includes the endpoints, and then we talk about positive and negative infinity. So if you look at these inequalities, the first one, x is greater than or equal to 2. We've already done that. That'd be a bracket, 2, comma, infinity, parentheses. The second one, x is less than 2, would be the same. It's already, not the same answer, but it's already something we've done. These last two are a little different that we haven't done, the compound inequalities. So with the first one, we're in between -1 and 5, including the 5. So what's different is we're not going to have an infinity or a negative infinity. So that would be a parentheses 1, comma, 5, and a bracket, because it includes the 5. And then the last one, x is less than -3 or x is greater than or equal to 4. Graph those, and then you're going to have two different intervals that work. So for the one on the left, that's going to go from -infinity to -3, parentheses at -3, or the other part that would work if you includes the 4. So you'd put a bracket 4, comma, infinity, parentheses. So with the or, it's got two separate parts for the interval notation. On problem 5, they kind of go the other route, and they tell us this is our interval notation, what would the graph be, and what would the inequality be. So if you graph it first, it would be a closed circle at -4 going to an open circle at 6. Since it's in between those two things, then we could just make it in between for our inequality. So our inequality would be -4 is less than or equal to x, which is less than 6. Part B, they have or. So they're asking how to graph that and then how we would write it in interval notation. So for graphing it, would be a closed circle at -1 going to the left, open circle at 2 going to the right, and then we just do the interval notation for each segment. So for the left part here, we do parentheses, -infinity, comma, -1 with a bracket, or for the other part would be, since it's an open circle, would be parentheses 2, comma, infinity, parentheses. So if you look at the got it 5, part A, they're wanting the graph and how we would write the inequality of that. So the graph, and that would always be my starting point. On a question, they might say, what's the inequality, and graph it. I'm going to graph it first because that's going to be a simpler process. It's going to be easier to see what's going on. So this is an open circle at -2 going to a closed circle at 7. And then the inequality, well, it's a segment, so that means our variable is in between two things. So we could say -2 is less than x, which is less than or equal to 7. Part B is just y is greater than 7. I'm not sure why they're including that here because that's not a compound inequality, but anyway, open circle at 7 going to the right, and that would be parentheses 7, comma, infinity. We're going to look at the lesson check number 3. So we've got some test scores. What possible scores can you earn on your next test to have a test average between 85 and 90 inclusive? Okay, so we've got 83 plus 87 plus whatever our next test is. For an average, it'll be divided by 3. We want it to be between 85 and 90 inclusive. So just like we did on the problems earlier, you can add in the numerator 83 plus 87 would be 170. And then they're dividing, so we could multiply by 3 on all 3 parts of the inequality to get rid of the fraction. And then we can subtract. They're adding, so we can subtract 170. And then we could figure out that we could get between an 85 and 100 inclusive in order to get that average of between 85 and 90. Number 5 just asks which are compound inequalities. For compound inequalities, it has to have or it has to have and, or if it's in between, a variable in between numbers, that would be a compound inequality also. So B is the only one that's not compound inequality. Number 6, it says the student writes the inequality in interval notation, bracket 17, comma, infinity, bracket. Explain why it's incorrect. It's incorrect is because a bracket indicates that a specific number is part of the solution. With infinity, it means it keeps going without end. So anytime we're using parentheses, or anytime we're using infinity or negative infinity, we should put parentheses next to it. So this gives you an idea of how to solve compound inequalities. Have a good day.